Thank you for watching our channels. I am Natasha, a representative of students from Mass Communication Schools. Today I would like to show to you the commentary of the designing of photobioreactor, or specifically the tubular photobioreactor, designed by our former students from engineering campus, Dr. Azaha. Today I would like to present to you Dr. Azaha and his PhD students, Ms. Nur Ain Fatiha. Before that, I would like to start with the introduction about this photobioreactor. A photobioreactor, or an algae bioreactor, is used for cultivating algae on purpose to fix CO2 or produce biomass. Specifically, photobioreactor can be used to produce fuels such as biodiesels and bioethanol, to generate animal feed, or to reduce pollutants such as NO2 and CO2 in fuel gases or power plants. Fundamentally, this kind of bioreactor is based on the photosynthetic reaction, which is performed by the chlorophyll-containing algae itself using dissolved CO2 and sunlight energy. The CO2 is dispersed into the reactor fluid to make it accessible for the algae. Dr. Azaha is one of the engineers who is helping the designing of this photobioreactor. So, Dr. Azaha, could you briefly explain or state what's the features in this design?
Oh, sure. No problem. So when we talk about tubular photobioreactor, which is tubular PBR in short, I would say, there is these two crucial parts that contributes the most in the yielding of algae production, and these two crucial parts that I mentioned is solar receiver and also the mixing unit.
Interesting, yet it sounds so complicated to me. Dr. Azaha, would you mind to explain the features in more details?
About that question, like I said just now, the crucial parts of the tubular PBR includes the solar receiver and also the mixing unit. But I'm going to add another one, which also contributes the most in yielding the algae production. I mean, optimizing the yielding of the algae production, which is lighting application. So first of all, I'm going to discuss about the solar receiver. So a solar receiver is also known as a continuous tubular loop. Now, a continuous tubular loop is a set of continuously recirculating of culture, which is usually algae, from one tube to another tube, and usually it is being pumped by the airlift or mechanical pump. So I'm going to show you this video while I'm going to describe the video itself. Okay, enough about the solar receiver. So now I'm going to touch on the mixing unit. So what is mixing unit? So mixing unit is actually known as bubble column. Now in bubble column, uh, liquid and gas phase occur on the same time in the column itself. So I'm going to show this one video while describing again. Done with the mixing unit. So next will be the light application. So for the light application, we use the emitting fiber optic light guides, and this sort of light exactly can be used as an individual light management, and to utilize small diameter tubes which being used in the production in order to optimize the algae growth. And for information, using this sort of light exactly is it produces light, but it's not going to generate any electricity, so it can be used in a wet environment. And for information also, using this light, it also generates light, but it doesn't generate any heat. So by in this sort of advantage, we're able to avoid any temperature levels that can detriment the algae development.
Hello, my name is Nurain Fatiha. I will tell you about the advantage of photobioreactor. The advantage of photobioreactor are it can produce higher productivity of algae because cultivation of algae is under controlled circumstances. Second, better control of gas transfer. Third, reduction in evaporations of growth medium. Fourth, more uniform temperature. Fifth, better protection from outside contamination. Sixth, space saving because it can be mounted vertically, horizontally, indoor or outdoor. And lastly, it can reduce fouling. Talk about the limitations of photobioreactor. The limitations of photobioreactor are difficult to control the culture temperature in most tubular photobioreactor. Although they can be equipped with the thermostat to maintain its temperature, this could be very expensive and difficult to implement. Another disadvantage is adherence of the cell of the walls of the tubes. Lastly, the increase in pH of the culture will also lead to frequent recarbonations of the culture, which will consequently increase the cost of algal production. That's all the limitations of photobioreactor.
Okay, Mira ucap sekejap ya.